Okay, we're on page 3 here. So let's have a look at this. So they've created a class for us here already called spaceship. And we've got the properties here, we've got a whole bunch of functions here. And they've inherited, they've created another class called fighter, which inherits from spaceship with a few variables and functions as well. So let's see what they would have us do. Define a new class, shield ship, that inherits from fighter. So fighter inherits from spaceship and shield ship is going to inherit from fighter. So let's go ahead and do that. So define a new class shield ship. So class shield ship, shielded ship that inherits from fighter. Okay, that's great. And add a variable property shield strength. Okay, that's cool. So var shield strength that defaults to 25. Sorry. Okay, we could do that. Create a new instance of shielded ship called defender. Okay, so var defender, right? Var defender equals shielded ship. So that's an instance of shielded ship. Set name to defender. Okay, so defender dot name equals defender, and weapon to cannon. So defender dot weapon equals cannon. Okay, call move right and print position, then call fire and print remaining firepower. Okay, let's go ahead and do that. So we've got call right. So defender dot move right. Oh, let's move left. Sorry, move right, and then print position. So print defender dot position. Okay, and then call fire. So defender dot fire. Okay, and then print remaining firepower. Print defender dot remaining firepower. Cool. All right. So we've done that. So this all comes from here. So remaining firepower was initialized as 5. Every time you call fire, it decrements remaining firepower by 1. Okay, that's everything here. And that's great. Let's go to the next section here. So it says go back to your declaration of shielded ship and overwrite was hit. In the body of the method, check to see if the shield strength is greater than 0. If it is, decrement shield strength by 5. Otherwise, decrement health by 5. Call was hit on defender and print shield strength and health. Okay, so let's see what we're gonna do here. So if we go all the way back to shielded ship, they said, which is right here, shielded ship. So let me just read this again real quick. Go back to declaration of shield and override was hit. So was hit is a function. Was hit was a function in spaceship. So we're gonna override it here. So we're gonna change it up a bit. In the body method, check to see if shield strength is greater than 0. If it is, decrement shield strength by 5. Otherwise, decrement health by 5. Call was hit. Okay, so that's not hard at all. Let's go here. Here's what we're gonna do. So to override a function to override a method that was in a parent class, we start with the keyword override and we type in func and we call the name of the function, which was hit. Okay, great. So override func was hit, and then they're telling us create a real quick quick if statement to check if shield strength is greater than 0, and if it is, decrement, so decrease shield strength by -5, right? Decremented by 5 rather. And then if it isn't greater than 0, what did it say? If it isn't greater than 0, decrement health by 5. We reduce health by 5. Cool. And that's pretty much it. Call was hit on defender and print shield strength and health. Okay, so now that we've done this, we're gonna go defender dot was hit, and then we're gonna go print defender dot shield strength, and shield strength is at 20 now. And if we print defender dot health, health is at 100. This makes sense because when we initialized this, shield strength was at 25, but because we called was hit, it took 5 away. In fact, if I print this thing right here before, it'll prove to you that this was 25, then we called was hit, and then it was 20. If I go ahead and call defender dot was hit again, and I print the shield strength, it should show 15, and it does. Beautiful. Okay, let's move on here. When shield strength is 0, all was hit does. When shield strength is 0, all was hit does is decrement health by 5. That's exactly what the implementation of was hit on spaceship does. Instead of rewriting that, you can call through to the superclass implementation of was hit. Go back to your implementation of was hit on the shielded ship and remove the code where you decrement health by 5 and replace it with a call to the superclass implementation of method. Call was hit on defender, then print. Okay, got it. So what they're saying here is, what we did here is decrement health by 5, but essentially we already have a function for that called was hit. So why don't we just, instead of being repetitive, just call was hit? And I'm gonna do that. Cool. And then what it wants me to do now is call it up. Okay, so let's do that. So defender dot, I'm gonna print the shield strength, and it's 15. And then if I call defender dot was hit and print defender dot shield strength, it should read 10 now. And if I keep calling this, it'll eventually get to 0, and my health will start decrementing by 5 to 95, 90, and so on and so forth. Cool, that's pretty much page 3. Let's move on to the last page, page 4. Okay, we're on page 4 here, and as soon as we get into page 4, there's actually 3 errors. And I think we have to fix these errors. So let's go ahead and look at the first instruction here. Note that each class above has an error by the class declaration that says class has no initializers. Unlike structs, classes do not come with member-wise initializers because the standard member-wise initializers don't always play nicely with inheritance. You can get rid of the error by providing default values for everything, yes, but it is common and better practice to simply write your own initializer. Go to the declaration of spaceship and add an initializer that takes in an argument for each property on spaceship and sets the properties accordingly. Then create an instance of spaceship below called Falcon. Use the member-wise initializer you just created. The ship's name should be Falcon. Okay, so we have to go back to spaceship and fix it and create a initializer. So that's pretty easy. So we go init, and then open bracket, and we're gonna say name. We're gonna say name of type string, and health. Well, health is of type int, and position is also of type int. Okay, and what we're gonna do here is we're gonna go self dot health. Okay, so self dot name. So when I say self here, what I'm doing is I'm actually referring to this name here, and you could tell it's a v, so it's referring to the variable. The reason I call self is because this thing right here, the init, is a type of closure. So you have to tell it what you have to write self to refer to the variables within that class. So self dot name equals name And when I choose name, you're gonna see two names here. The v refers to this variable right here. The L refers to this parameter that we're following, this argument that we're passing through. So obviously I'm going to choose the L. So what I'm saying here is whatever value, when someone initializes this spaceship, whatever value they put in name, take that value and place it in this name variable, or rather constant. Okay. We're going to do the same for the other two properties, like health equals health. And then self dot position equals position. Beautiful. Let's see if I chose the right one here. I got confused there for a sec. Yes, I did. And that should get rid of the error. And yes, there's only two errors left. This error here is gone. So let's see, what else do they want us to do here? So it says go back by the but it's common practice. So go declaration of spaceship and add initializers that takes an argument for each property of spaceship. Okay, we did that. Then create an instance of spaceship called Falcon. So var Falcon equals spaceship, and we have to initialize it now. Now we have a custom initializer that looks awfully a lot like a member-wise initializer. Use the member-wise initializer you just created, exactly. And the name should be Falcon. And they don't really give us the values for these two, so I'm just gonna go health 100 and position 50. Okay, writing initializers for subclasses can get tricky. Your initializers need to not only set the properties declared on the subclass, but also to set all the uninitialized properties on classes that it inherits from. Go to the declaration of fighter and write an initializer that takes an argument for each property on fighter and for each property on spaceship. Set the properties accordingly. Hint, you can call through to a superclass initializer with super.init after you initialize all the properties of the subclass. Okay, then create an instance. Okay, so let's go back to fighter and try to fix this error. So what we do here is we type in init, and well, sorry about that, and I'm gonna get rid of this, hold on. So init, and what we do is we open the bracket here and we're gonna type in weapon, right? Because we've got weapon here, and that's of type string, and we've got remaining firepower, and this is sort of tedious, to be honest, but it needs to be done. So you're thinking that's it, but actually no, we got to call up all the other properties here in the superclass, because remember, fighter is inheriting from spaceship. Got spaceship here, so we've got name, health, and position. So name, which is of type string, health, which is of type int, and position, which is of type int as well. Okay, and now we need to initialize all of this. So self dot weapon equals weapon, and self dot remaining power equals remaining power. Now for the other three, I'm not gonna have to rewrite every single line like this. What I'm gonna do is simply call super dot init, and it opens this up for me, and all I'm gonna do is say name, health, and we're gonna choose the L, and position. Perfect. So essentially I called the super. By super, it's like the super class or the parent class. So I'm essentially calling the initializer from this thing right here. Cool. All right, and that error is gone, and we've only got one error left. So if we go back here, it says then create an instance of fighter called destroyer. So var destroyer of type fighter, and the name is the ship's name should be destroyer with an uppercase D, destroyer. and remaining firepower, and I'm gonna say 25. Sorry, use the ship's name should be destroyer, so that's the name right here, destroyer. And weapon, I'm just gonna say, I don't know, laser maybe. And health, we're gonna give it 100. And position is 50. Okay, health is 100. And that's good. Okay, we're done here. Okay, so now go add an initializer to the shielded ship, which is right here. It's the last error we've got. That takes an argument for each property on the shielded ship, fighter, and spaceship, right? Because shielded ship inherits from fighter, and fighter inherits from spaceship. So spaceship is the parent class of fighter, and fighter is the parent class of shielded ship. So it's a lot of inheritance here. And sets the properties accordingly. Remember that you can call through to the initializers of fighter using super.init. Then create an instance. Okay, so let's go ahead and do that. Shielded ship. Let's go ahead and create an initialization here. So we type in shielded strength, right? And that's of type int. And that's really the only new property we have. But the old properties were weapon and remaining firepower. So weapon is of type string, remaining firepower of type int, and the original three were name, health, and position. So name is of type string, health is of type int, and position is of type int. Okay, and now we're gonna initialize shielded strength, sorry, self dot shielded strength, self dot shielded strength equals shielded strength. And for the other two, we're gonna call up the super dot init. In fact, we only have to call up one, because what I'm going to do is I'm going to call up this, which has everything, and that has the top as well. So weapon, we're going to say, I don't know, rockets, remaining firepower 30, name, I'm not sure what the name is going to be here. Oh, sorry, I'm not filling this thing out. What am I doing? I'm being silly here. So I just type in weapon here. Remaining power is going to be remaining power. A name is going to be name. Health is going to be health. And position is going to be position. Great. If we go down here, now it says create an instance of shielded ship called defender. So we're going to go var defender equals shielded ship. Oh, there it is. And we're going to initialize it, shielded strength, we're going to go with 30, weapon, maybe rockets, remaining firepower, 30, name, they're telling us the name should be defender, and health at 100, and position, we're going to go 50. This should work, except Xcode is hanging again, so I'm going to quit Xcode and relaunch, and I'll be back. Okay, so I'm back here from relaunching Xcode, and this worked, and as you could tell, there's no more errors because now we've created initializers for spaceship, for fighter, and for shielded ship. Okay, great. The last little bit here is create a new instance of spaceship called same ship. So we're going to go var same ship and set it equal to Falcon. Equal to Falcon, equal to Falcon. Falcon is, let me remember here. Falcon is this thing right here. Okay, so we're just creating another we're copying it essentially. Print out position of spaceship. So okay, I see what they're trying to prove here. how it references to memory rather actually copying. So we're going to print the position of so print out position of same ship and Falcon. So we're going to print same ship dot position, and we're going to print Falcon dot position. And not sure why it says I have an error here. No, I don't. Okay, so 50-50, great. Then call move left on same ship dot move left on same ship, and print out the position of same ship and Falcon. So print out the positions again, and it's gonna say 49-49. Did both positions change? Why? If both were structs instead of classes, would it be the same? Okay, so why or why not provide your answer in a comment. So simply said, when you are copying instances in classes, what you are essentially doing is merely making a shortcut, if I may. I'm not sure what the exact word to use here. Making a shortcut or making another reference of the same object in memory. So essentially, when I copied, when I made same ship and I gave it a value of Falcon, I didn't actually copy anything. I didn't make another instance. What I did was I created a shortcut, and both same ship and Falcon point to the same space in RAM, the same space in memory that holds the instance of that class. However, if this were to be done in structs, and this is one of the differences between structs and classes, if this were to be done in structs, there would actually be two unique I guess instances of the ship, and each would have their own identity, whereas in classes they both share the same identity. Cool. So if we were to do this in structs, it would actually go out in memory and create another space in memory that holds the info for same ship. So if you change a value in same ship, it changes that space in memory, and therefore the value of some variable in same ship would differ from Falcon. Whereas in classes, they're going to be the same always, because no copying has been done, merely a shortcut, if you may, has been done. And that's one of the few differences between structs and classes. That as well as inheritance, that's the second one. And the third one sort of is how classes handled initialization, as opposed to structures already have the member-wise initializers, and you don't have to make it from scratch. And that's essentially it. That's the end of the lab for classes. Hope you've enjoyed. Thank you for watching.